All right, welcome. Today, we're going to peel back the curtain on something we use every single second, but almost never actually see, the internet itself. We're going to take a journey, layer by fascinating layer, to figure out how it all really works.
Just think about it for a second. You hit send on an email, and poof, it zips halfway across the globe in less than a second. How in the world does it navigate that insane maze of wires and signals to pop up on the exact right screen? It feels like magic, but I promise you, it's actually a brilliant, super organized system.
So how do we even begin to wrap our heads around this? Well, let's use an analogy that just makes it all click. The whole complicated dance of digital communication is surprisingly a lot like something we all get: sending a letter.
Right? When you mail something, you follow a few simple steps. You write the letter, stick it in an envelope, slap an address on it, and drop it in the mail. You don't need to know the pilot's name or the delivery truck's route. You just trust the system to handle it. Well, the internet works in a very similar way, using a set of rules or layers to get the job done.
This whole layered idea brings us to the master blueprint for how networks are supposed to talk to each other. It's officially called the Open Systems Interconnection Model, but pretty much everyone just calls it the OSI model. So picture this. It's the late 1970s. The digital world was kind of like the Wild West. You had all these different computer systems from different companies that couldn't easily talk to each other. It was a mess. So the International Standards Organization stepped in and created this universal blueprint, this common language, to make sure any machine anywhere could communicate.
We're going to start our journey right at the top with Layer 7, the application layer. This is the part of the internet you actually see and touch: your web browser, your email client, whatever game you're playing online. It's the interface between you and the network.
Just below that, we've got Layer 6, the presentation layer. The best way to think about this one is as the network's universal translator. It takes the data from your app and makes sure it's in a format that the other computer can actually understand. It also does super important jobs like compressing data to save space and encrypting it to keep it safe. Next up is Layer 5, the session layer. This is basically the conversation manager. Its job is to open up, maintain, and then close the communication link between two devices. It's like a moderator, making sure the dialogue is orderly and that the messages don't get all jumbled up.
Now we get down to Layer 4, the transport layer. I like to call this one the quality control manager. It takes big pieces of data, like a photo you're uploading, and chops them up into smaller, numbered chunks called packets. Then, on the other end, it reassembles them in the right order and double-checks that nothing went missing along the way. It's all about reliable, end-to-end delivery.
Okay, now we're getting into the real logistics. Layer 3, the network layer, is like the internet's global postal sorter. Its one and only job is to figure out the best path for your data to travel across all the different networks to get to its final destination. This is where that routing magic really happens.
Layer 2, the data link layer, is more like your local mail carrier. It's not worried about the final address in another country. Nope, its only job is to get the data packet to the very next stop, or hop on its journey, like from your laptop to your Wi-Fi router.
And finally, we hit rock bottom. Layer 1, the physical layer. These are the actual roads and trucks of the internet. The fiber optic cables buried underground, the copper wires, the radio waves beaming from your Wi-Fi. This layer is what turns all that digital data into physical signals, flashes of light, electrical pulses, or radio waves, and sends those bits on their way.
So, okay, we have these 7 layers, but how do they all play together? Well, it happens through a process called encapsulation, which is just a fancy way of saying putting a letter inside a bunch of envelopes. Our postal analogy is perfect for this. See, as your message travels down through the layers on its way out, each layer wraps it in its own envelope, or header, with specific instructions. The application layer makes the message. The transport layer breaks it into numbered pieces. The network layer adds the final global address, and then the data link layer adds the local address for just the very next stop.
Now here's a really important point. That 7-layer OSI model is a fantastic theoretical guide. It's the perfect blueprint. But in the real world, the internet we actually use every day runs on a more streamlined, practical version called the TCP/IP model.
Just think of it like this. The OSI model is the super detailed architectural drawing, but the TCP/IP model is the actual building that got built. It's just a bit leaner and it combines some of the OSI layers because in practice their jobs are really closely related. So in the TCP/IP model, they basically took those top 3 OSI layers, application, presentation, and session, and just smushed them all together into one efficient application layer. The bottom layers, though, they map pretty much one-to-one, handling the transport, the networking, and the physical stuff just like in the blueprint. All of this, the layers, the packets, the routing, none of it works without one absolutely critical concept: addressing. Just like our good old postal service, the internet needs a totally reliable address book to make sure data gets exactly where it's supposed to go.
Now here's the cool part. To get a message from a specific program on your computer to a specific program on another one across the world, the internet actually uses 3 different kinds of addresses, all working together as a team.
First up, you've got the physical address, which you'll also hear called a MAC address. Think of this like a permanent serial number that's burned into your device's network card. It is only used for local delivery, getting your data to the very next device in the chain. It's the address for the next stop, not the final destination.
Second is the logical address, or the IP address. This is the one you've probably heard of. This is the big one. It represents the final destination computer, anywhere on the planet. And what's crucial is that this address stays the same for the entire journey.
And finally, the port address. This is key. If the IP address gets the message to the right building, the port address gets it to the right apartment number. It tells the computer which exact application, your web browser, your video game, your Netflix stream, that message is for.
So if there is one thing to take away from all this, one core concept, it's this. As your data packet travels the globe, its local, physical, MAC address changes at every single stop, but its logical, IP address, that final destination, that stays constant from the very beginning to the very end.
You know, this incredibly elegant, layered system was designed way back in the 1970s, long before anyone could have imagined a world with billions of connected devices in our pockets, on our wrists, and in our homes. It's been amazingly resilient, but it really leaves us with a huge question. As our world gets even more connected, what will the next evolution, the internet's next layer, even need to look like?